Hi guys, hello and welcome to our talk on the 2020 event-driven microservice conference. Unfortunately, this year we cannot meet in person. Simon and I attended the 2019 conference last year in Amsterdam, so hopefully we met some or most of you already. Of course, 2021 will be better in this regard. Our talk will be about Axon and Kotlin. We called it an expected journey. You might have heard of Tolkien's unexpected journey, which is still more popular than our journey. We think that Kotlin and Axon are a perfect match, and that the steps we took on our way to merge those two technologies were somewhat forced and obvious, so this is our expected journey. Yeah, we won't have any dwarves or hobbits, but we will find a treasure at the end, hopefully no dragon, and of course there will be some magic involved. So who are we? I'm here today with Simon, my name is Jan. We are both senior consultants at Holisticon. We have offices in Germany, in Kiel, Hanover and Hamburg. Together we have about 40 years of professional IT experience, mostly in consultant projects based on Java, JVM, JE, that kind of stuff. We both really love, and use free and open source software. We are regular contributors and authors of projects you will find on GitHub. Most of the work we did over the last years was done in the context of the Camunda process automation platform. In case you're not familiar with it, Simon will have an example later where we explain more what this does. We learned about Axon, started using it about 3 to 4 years ago, when we noticed that this shift from the classical 3-tier architecture to microservices in our customer projects occurred. And it was obvious that the old ways we did things before just don't work anymore. And somehow immediately fell in love with it, and take some time to really get the grasp of this concept of event sourcing, CQRS. But right now we already did a couple of projects with Axon Framework and Axon Server. We won't cover this in depth today because there are other talks on this conference which deal with how to get Axon Server into your existing architecture. But over the years, we also did some contributions to the Axon framework, like extensions. You might know the CDI extension, the Kafka extension, and today we will talk about the latest contribution, which is the Kotlin extension. Okay, so what will this talk be about? Of course, we will motivate why we think that Kotlin and CQRS event sourcing in general, and Kotlin and Axon framework in particular are a great match. Simon will share some example projects we did with Axon and Kotlin over the last years, both for fun and profit. And then we will tell you about the current state of the Axon Kotlin extension, which is available on GitHub. And actually, the idea to making this features an extension grew last year on this conference in Amsterdam, where we saw a talk where Jan Hendrik presented some API improvements he did with Scala. And we were already big Kotlin fans back then. We saw it and said, okay, this is a challenge. Accept it. We want to do this with Kotlin. And this is what we reached so far. So Axon and Kotlin. In case you never heard of Kotlin before, it's this new, hip, popular language for the JVM platform. Actually, it's not that new. It's about 10 years old, but it just entered this hype curve and got popular 3 to 4 years ago. It's JVM language, is statically typed. So we keep all this compiler greatness when we code. It shares with Java this object-oriented paradigm, but also adds a functional paradigm we know from other languages, as Scala. And it brings a lot of improvements to a pure Java platform by having built-in immutability and null safety. And compared to Java, it's a very concise language, so you can express very much with fewer lines of code, which is very useful, as we will see. And personally, my opinion is that over the last years, it somehow became an innovation hub for Java, because ever since Java 8, or 11 to be fair, I didn't see any major feature in the latest Java versions that I didn't knew already from Kotlin, like record type data classes, coroutines, that kind of stuff. Okay, why Kotlin and CQRS and event sourcing? As you know, the C, the Q, and the E are command, event, and query. And those are supposed to be immutable objects. So once you store an event or send out a command, you don't expect anyone to mess with it, change values, influence your history and your event store. And a language that has built-in immutability features is great for that. You, of course, can do this with Java, but only with very clever development or use of external frameworks. And to deal with those events and commands in event sourcing, you have a lot of small functions that are more functions like object methods, and a functional paradigm fits greatly to this. And why Kotlin and Axon then? Obviously, we consider Axon framework to be the kind of reference implementation of CQRS ES on the JVM platform. We love Kotlin, we love Axon, so yeah, perfect match for us. Funny story at that point, I actually learned about Kotlin, or not really learned, but saw it the first time in action in a webinar presented by Alard a few years ago, where he wrote the whole system, aggregates everything in Java, but he used Kotlin data classes for commands and events. That led to that when I showed this new cool thing I just spotted to my colleagues, they asked me if they can do this in Java, or if they have to learn Kotlin to do this. So this is my personal history with this, which motivated me to really dig deep into Kotlin. Already said, data classes, command, event, query, and this conciseness and the ability to use expressions as functions and functions as first-level citizens fits greatly to this command and event handler programming we do in Axon, because we have a lot of very small functions that in Java just use a lot of space on your screen, and with Kotlin they are really one-liners.
Okay, so I think it's my turn. Hello, everyone. I'd like to present some example projects and give you some, kind of some feeling how this Kotlin fits to Axon framework and how this can be used together. So the first thing I want to share with you is a framework actually that we built, which is called Camunda BPM Task Pool. It leverages the existing Camunda platform for process automation and enables there some features that you need in distributed scenarios. So what we did is we created the framework to support this, and using process automation is a lot about user task management. User task is basically the concept of an abstraction in your system where humans interact with the process engine. And Camunda started their product in kind of historically monolithic scenario, and later on they moved on to this basically jumping on the microservices hype. So they had to kind of deal with this and decided not to do this in the original project. But in these microservice scenarios, you don't have just just one monolithic engine standing somewhere where all the processes run, but you tend basically to say, every process, every single small domain is its own microservice. And so you have to somehow integrate all these user tasks coming from various engines. And so this is exactly what this command and BPM task rule is built for. So what we use there is completely written in Kotlin. It's Spring Boot-based framework. It uses, of course, Axon framework. It uses, of course, command and BPM, since it's leveraged this. We use the Kotlin extension, and then depending on the scenario that you use, you basically can opt in to use Axon Server for the distribution. This is the kind of design scenario to do so. But if you can't, then you basically use the flexibility of Axon framework, and you can distribute your events using, for example, Kafka. So there is also a project by our customers where we basically are not using Axon Server, but using Kafka for distribution of events. So let me give you a small overview of the architecture of this system. So basically you can see here two major blocks. On the left side, there are various process applications, which usually include the process automation system, the engine written from Camunda. And this is leveraged with some components which are responsible for sending out commands regarding the user tasks and some additional stuff to a central process platform. And this central process platform is a usual UI integration point where your end customers will see their user task basically displayed, and where you have a kind of an inbox for the task list, what a person has to do. And also some archive view for the work pieces that have been processed by the applications. And so the interesting here is that we basically use these nice abstractions of buses provided by the Axon framework, and can kind of basically distribute the system fitting our scenario fit. Actually, this is very powerful in that place, and I personally know no other framework where you can configure your distribution later on after the system has been built completely. So you can move components around, and this is a very strong feature. So for, as I already said, it's completely built in Kotlin. And so just give you an example where we use the Axon Kotlin extension. So you're probably familiar with the concept of a command gateway. So that's the guy who accepts commands for Axon framework. And usually you have to specify the types of the command and the return type, what they're expecting back, basically, if you're calling the command gateway. This is you can kind of bypass this basically using the Kotlin extension. As you can see here, the command gateway just sends the command without explicitly specifying the type, because Kotlin has this powerful feature of inferred types. And later on, Jan will show the magic how this works. So this is kind of just a very small modification to the original code, but still it's part of the extension, so we wanted to share this with you. Okay, let's go on to the next project. This is not open source, very seldom for us that we are doing something not open source. It's called Ranked, and it's basically a table soccer reporting app we are building. So in this app, we basically do several things. So the idea is that you play table soccer in your company, and Holisticon is a table soccer company. So we have tables here, and we, every free minute from work, just to relax, you just go and play table soccer with your colleagues. So we had the idea of building a kind of a small application running on a mobile phone. And so you have a mobile phone lying on the table, actually, and you can count the scores on this mobile phone, and later on get all the statistics about the game, about the scores, about the timings, and everything else. And then, born as kind of an internal project, this grew up to kind of idea of producing this app to the public. And so we had some guys that did some recent interviews with professional players, actually, of table soccer. So we run the kind of a field study with questionnaires, what people need outside there. And all this follow actually the concept or concepts from domain-driven design. So we even did the event storming session on this product to find out what will be the different parts of the application, how are the domains, what are the contexts, what we are going to build. So it was very interesting. It's completely CQRS based, so no classic three-tier Java EE style application. And since we are using mobile phones for the communication, we decided to go full reactive. So basically, we are pushing any kind of information to the mobile phone using server-sent events. From the tech stack, it's again Kotlin and Spring Boot. We previously started with Ktor, but decided for a more solid framework, basically, since we want to produce this to the public at some point. And so currently it's not released to the public, it's only for internal use, but it will be released. We use, of course, Axon framework. We use Axon server in this project, the Kotlin extension, the React extension. And let me share you some patterns and learnings we had actually in this project. So the first learning, it's kind of maybe obvious for you guys, but if you follow the DDD rules, life becomes much easier and much better. So if you do strategic modeling in advance, if you cut your contexts based on basically your customer experience and your customer knowledge, then your architecture becomes clear and you get much cleaner code, not cluttered. It feels really nice. And this second learning, that was kind of a surprise. So we trapped in, basically, it was a mistake in a previous version of that any kind of configuration changes you do in your application is essentially a command. So you cannot rely on static configuration in some configuration file or whatever, because you have append-only event store and it becomes invalid for later. And you think table soccer, what kind of configuration do I need there? But in essence, it's very interesting because there is a lot of stuff that influence your game mechanics, actually. So if you want to open this and not only building it for your in-company rules, but you say, okay, there are maybe a different set of rules you can play with. So you can say, I play one game, or the game consists of several matches, and you have to configure how many matches you have to play to win, how many goals you have to score. Is there a mandatory player switch after each game, or is there a draw mode, and so on, and so on, and so on. So it's kind of a predefined set of configuration you need basically to do in advance before the actual game starts. And this influences how this game works and basically what commands are valid and what commands are later not valid anymore. So it becomes kind of non-trivial even in this very funny scenario. So with this raising complexity, we understood that there are several parts basically of this application. And the one part is basically that we do this game playing. And the other part is basically that we have to arrange everything around this, basically to follow the framework, Axon framework in this case. And so the pattern is a clear pattern from domain-driven design. It's called functional core imperative shell. So we basically kind of separated our code base to something that is pure functional, which is the game playing functional core. And basically all this around this to embed this into the Axon framework, which then becomes an imperative shell. And the last, maybe kind of easy learning, but this is one of the promises, and we proved that correctly, actually, that this holds also for our case, that we started with aggregates and we started with game playing because this is kind of the core of the application. And then the projections will follow you later on. So basically, you kind of can start with the gameplay and later on add statistics and end tournaments and so on and so on, and you don't need to change your existing software. This is very, very interesting. So let me show you some code snippets. We are in developers for developers, so we should have some more of these code slides. So this is what I mean by the functional core. So in this example, you can see we're using a Kotlin data class, match, which is, in this case, holding two values, and basically, so you cannot modify them, so they're immutable. And something like scoring a goal, in this case, is actually not modifying the existing match, but producing a new copy of this match, which has then the new state in it. So you are not mutating your state, but you are just creating a new state. And this is what we mean by this pure functional approach. And on the other hand, this needs to be embedded into the aggregates, so somehow, and this is the imperative shell. So we, of course, have the match aggregate that holds this immutable core, in this case, a match. And so handling of a command is done as usually in Axon. So we are firing some events, and then the event sourcing handler has to mutate this state of the aggregate, basically assigning the match value to basically the new value produced by the functional core. So this is how this separation works. As an idea, and this is where, as Jan already said, we are kind of a little bit not fulfilled the Scala challenge yet, but we're planning to do so, is to get the aggregates immutable too. So, but he will tell about this a little bit later, how that works. Another thing I told you was the reactive nature of the application. So we had to basically, so we went with Spring Boot Webflux, which makes you feel really good programming Mono and Flux, so basically project reactor artifacts. And so basically your REST controller mutate to a routing function that, you know, delegate everything to reactive handler functions actually. And here is an example of this. So basically this is how it works. So in the gameplay you have this moment where you say, I want to register my cell phone for this table. So we have this basically join a match request, which is a command basically sent to the match essentially. And as you can see, we need first basically, so since we are fully reactive, the request is a mono, so we have to resolve that. Then we have to read some parameters out of that. Then we don't have the information for the command sending directly in the request, but we need to set up a query. So we query our own projection to find out the correct table name actually. So we get the match info from the match identifier. Then from this match info we can read out the table name and then send out the command that this device is put on that table. And if you know how this looks like in Java, then you would notice that basically the query method here is returning a result, and then we call flatmap directly on that. And this is because we're using the reactor extension here. So the reactor extension leverages the standard gateways of Axon framework and provide us with return types mono and flux instead of completable futures. But still, so it also holds for the command gateway. So also there, we will basically return a mono, and only after all these monos complete, we send out the response. The kind of a remaining problem in this example is that you see that basically programming reactive functions tend to fold in your code. So in this case we have 3 monos, so we have 3 times folded in code, and it gets it deeper and deeper and deeper. If you have it 7 times, I don't think that this is manageable code anymore. And this is exactly the place where I would like basically to use Kotlin coroutines, where you can just write sequential composed concurrent functions one after another, and you don't have this callback hell basically built in. Yeah, and during all building of these projects, we kind of stumbled upon on a framework that we also use in different other projects by customers. And so we integrated them together. So we built a small library which is called Axon JGiven. So I will just show you, it's not a real great project in terms of a lot of code or whatever. It's based on the Axon test fixtures that are provided by the Axon framework itself. But it leverages with and combines it with the existing framework called JGiven, which is produced for the kind of any JVM language. And so we combine two very powerful tools here because JGiven is producing very nice, very decent reports, which can be read by customers, for example. So we kind of integrated these two worlds together. JGiven uses a slightly different concept for these given when then basically statements. So they call this stages, and these stages are used for transferring state between inside of your test actually. So how it looks like, it's very similar to the Axon fixture. So essentially, the only difference here, you can see that the call is not completely fluent, but we have three different calls, which is given when then. We wrote here in capital letters because when is in small letters is basically a keyword in Kotlin, so we had to bypass it somehow. So it looks very similar to every person who already used Axon framework features. But the next slide shows why JGiven could be a good idea. So essentially, you can produce a very nice report which is, in this case, a HTML report page showing you basically the single scenarios. Maybe one of you is familiar with the same stuff coming from Cucumber or from JBehave or other JVM frameworks for BDD. Okay, so that was the short journey of our projects. And take over to Jan.
Okay, thank you, Simon. Now we reached this point of our journey where we have to put up this caution red floor sign. The Kotlin Axon extension we mentioned before got released, so we have something out there. It was actually not even finalized and released by us, so thank you to the other contributors, to Stefan's actually. It's 1 month old now. It's out in version 0.10 and has this big experimental flag on the README on GitHub. So use it at your own risk, but trust us that it works and has proven to work in several projects already. We have, Simon has shown you the extensions to the Java Axon API. What we didn't show you is a simplified way of writing event upcasters in case you have to change how you deal with your stored events later. And now I'm, like this very light magician who reveals the trick later on. Just if you're not familiar with Axon, with Kotlin extension functions and type system, this is what we, for example, use for the query gateway. So the query gateway you see here is the actual class from the Java API. And you can write a new function in Kotlin, in this case a query optional, which then in Kotlin can be used as if it would be a function on the actual API, but it is not. So it looks like magic. feels like magic. It is not magic, at least not black magic, because if it is static, it becomes a static function in JVM bytecode later on, where just the first parameter is your query instance and the other parameters are added to it. And this I can leave out generic type information is done by this inline reified. You see we have a result and a query type for this query. What the Kotlin compiler does here is to inline it, so this function is copied in the bytecode to the place where it's called, and therefore we still have some issues because this is JVM, but we have not this hardcore Java type erasure generic problem here, and can leave out certain type information when we work with it. Okay, for this Axon Kotlin extension, we have accepted the Scala challenge. We did not fulfill the challenge yet because, as Simon also told you, we want to have immutable aggregates. I have a very blurry picture of the slide from last year's presentation with Scala, and a promise that we will continue the discussion later on. So this is top on our agenda. We learned, and Simon showed that also, that when we want to get this reactive behavior done, we have to bring the two extensions closer together. We actually cheated because the query example Simon showed you was based on an internal Kotlin extension function that is not already part of the published extension to achieve this. And we want to get rid of this callback hell by using coroutines for concurrency. Okay. We reached the end of a journey. To sum it up, Axon framework is great. The people at Axonic are great and helped us getting this idea of a new community extension up and running. We think it's a great way of contributing to an open source project. We don't have to argue about features and backward compatibility in the core framework, which is partly commercially used framework as well. We can just spin around and get ideas, get them published, try them out in public, and maybe at some point in time integrate them back into the core framework. And if you now became motivated, you want to contribute, you say, this is a great idea. There are open issues, just contact us, contact Steven, file an issue. And then we're looking forward to discuss this with you. We have time for questions now.
Thank you.